Alright, boys and girls, welcome to our next video lesson in Chapter 2, Section 5, our lesson on solving polynomial functions with imaginary roots. Let's just listen to the music for a quick second here. Okay, the first thing we need to talk about are complex conjugates and the complex conjugate theorem. We know that the complex conjugate of a plus bi is a minus bi. So if I had a root like 3 plus I know that also 3 minus I is also a root. If I have a root like 4 minus root 2I, I know that 4 plus root 2I is also a root. And lastly, if I have a root of something like 7I, I know that negative 7I is also a root because we could put a 0 in front of each of those. Okay? Complex roots will always come in pairs because the complex root and its conjugate are both always roots of a polynomial function. Okay, there's two theorems you need to know. The fundamental theorem of algebra says that if any polynomial function of degree n is going to have n number of roots in the complex system. Of course, some of those roots could be double roots. Some of those roots could be imaginary roots. And as we just mentioned, the complex conjugate theorem says if a plus bi is a root, then its conjugate, a minus bi, is also a root. So if we're looking at this problem right here, write an equation with the following roots. I know there are going to be three factors. My first factor is x minus 4. That's going to come from the 4. I also have a root of x minus 3i. That comes from the root of 3i, and I'm also going to have a factor of x plus 3i. The easiest thing to do right now is use our sums and products and take these two factors, and as opposed to foiling them, we're going to use our sums and products to come up with the quadratic factor. So I'm going to take 3i, and I'm going to add the two roots. 3i plus negative 3i is equal to 0, and I'm going to multiply these two roots. 3i times negative 3i is equal to negative 9i squared, which of course we now know by now that is equal to positive 9. So therefore, okay, so now I know that the sum of my roots is 0. That's equal to negative b over a. And I know that the product of my roots, which is 9, is equal to c over a. So we can see now that a is 1, so I have 1x squared. B is 0 plus 0, and c is 9, so I have a factor of x squared plus 9. I also have a factor of x minus 4. I'm now going to FOIL those out, and I'm going to get, do it in blue, x to the third minus 4x squared plus 9x minus 36. So there, running out of room here, is my equation with the following roots. Okay, looking at this one, same thing. We're going to write the equation with the following roots. I have three roots, which gives me three factors, which of course the first one is x plus 1. And now I'm going to use my sums and products to figure out my quadratic factor. So I'm going to take 6 plus 5i and 6 minus 5i and add them up. 6 plus 5i plus 6 minus 5i. That is equal to 6 plus 5i. Well, the 5i's are going to cancel, so let's just cut right to the chase. That's 12. And of course, that is equal to negative b over a. I'm going to multiply them. 6 plus 5i times 6 minus 5i. Well, those, when we multiply, we know that we are going to get, those are conjugates, so we're going to get 6 squared, which is 36, minus 5i squared, which is 25i squared. That, of course, then becomes 36 plus 25, which is, don't tell me, I'm doing that math, 61. That, of course, is equal to c over a, so I now have a quadratic factor of a is 1, so x squared. B is negative 12. C is 661. I'm going to take those and I'm going to multiply by x plus 1. I'm now going to FOIL this out. I'm going to get x to the third plus x squared minus 12x squared. I'm just going through here. There's my x squared. Here's my minus 12x squared minus 12x plus 61x plus 61. So it looks like this whole thing, I'll write this in red right down below where we can see it. It's going to be x to the third, x squared minus 12x squared is 11x squared minus 11x squared. I forgot an x right there. Minus 12x plus 61x is plus 49x plus 61. Okay, looking at this guy right here, I can see that I have 1, 2, 3, 4, 5 roots, so I know that this is going to have a fifth power polynomial function. My 0 gives me a factor of x minus 0, which is x. My second 0 gives me another factor of x minus 0. My 4 gives me a factor of x minus 4. And then I have 1 plus I root 2 and 1 minus I root 2. If I add these two, I'm going to take these two and add them. So 1 plus I root 2 plus 1 minus I root 2. The I root 2's will cancel. I get 2. So 2 is equal, that's my sum, is equal to negative b over a. If I multiply these, I have 1 plus I root 2 times 1 minus I root 2. So 1 times 1 is 1 squared, minus I root 2 squared, that's I squared times 2, which of course now becomes positive 2. So I have 1 plus 2 is 3. So 3 over 1 is equal to negative c over a. So I have a quadratic factor of a is 1, x squared. B is negative 2. C is 3. I need to multiply that by x squared and by x minus 4. Probably the easiest thing to do is distribute the x squared right now. So I'm going to have x squared minus 2x plus 3 times x to the third minus 4x squared. I now need to do a double FOIL. I have run out of room, so I'm going to let you do this. And first 5 people to email me with the correct answer will get a bonus point. Moving on. Okay, here now we're going to go the other way. We're given the equation. We got to come up with the roots. As I look at this one right here, I could do my Descartes' rule of signs. I could use my P's and Q's, but looking closely here, I see that yes, this guy is factorable. Factors of 27 are 9 and 3 that have a difference of 6, so therefore this is going to be factored as x squared plus 9, x squared minus 3, which means now x squared is equal to negative 9, or x squared is equal to 3. I'm going to take the square root of both of these, so x is equal to plus or minus I root 9, which is 3. I guess I should probably, let me erase for a minute. That's going to be plus or minus 3i, and x squared is equal to 3, so x is also equal to plus or minus the square root of 3, which means my roots are positive root 3, negative root 3, positive 3i, and negative 3i. I have 4 roots. I have a power of 4, so everything checks. Here's one more. This time we're given a polynomial with a power of 3, so I know there's 3 roots. I know that one of them is 3i, which means now I also know that negative 3i, its conjugate, is also a root. If I add these 2 roots up, I get 0. That's equal to negative b over a. If I multiply them, I get negative 9i squared, which of course is positive 9, so that's equal to c over a. So I have a quadratic factor of 1x squared. A is 1, so 1. What's going on here? 1 x squared minus 2x plus 3. 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 1 x squared minus 2x 1x squared. B is 0. C is 9. I'm going to divide that guy into my original problem. So I have x to the third plus x squared plus 9x plus 9. X squared goes into x to the third, x times. I'm going to multiply through. I have x to the third plus 0x squared plus 9x. I'm going to change my signs, get a different color, minus, minus. X to the thirds go. I bring down the x squared because I have x squared minus 0x squared is 1x squared. The 9's cancel out. I bring down the plus 9. Notice now I have x squared plus 9 goes into x squared plus 9. That's 1 time. If I multiply through, I sure enough see that my remainder is 0. So I have also a factor of x plus 1. So my three roots are going to be 3i, negative 3i, and negative 1, because I have a factor of x plus 1. Let's try one more here. I have a power of 3, so I know there's going to be 3 roots. I have one root of negative 3 plus I, which means I also have a root of negative 3 minus I. If I add these two roots, I get negative 6, so negative 6 over 1 is equal to negative b over a. If I take these two roots and I apply them, negative 3 squared is 9. 9 minus I squared is 9 plus 1, which is 10. So I have I have a product of 10 that's equal to c over a. So I now have a quadratic factor of a is 1, so x squared. B is positive 6. C is 10. I'm going to divide that into my original problem. 4x to the third plus 23x squared plus 34x minus 10. Never enough room. X squared goes into 4x to the third, 4x times. I'll just write that up here. I'm going to multiply through. 4x times 4x squared is 4x to the third. 4x times 6x is 24x. 4x times 10 is plus 40x. Change my colors so I can change my signs. Minus, minus, minus. 4x to the third minus 4x to the third is 0. 23x to the third minus 24 squared minus 24x squared is negative x squared minus 6x minus 10. It looks like that's going to go in minus 1 time. I'm going to multiply through. I get neg x squared minus 6x minus 10. If I change my signs, these all will cancel. Sure enough, I have a remainder of 0. So I have another factor of 4x minus 1. If I set that equal to 0, I'm going to get 4x is equal to 1 and x is equal to 1/4. So I have a factor of 1/4, negative 3 plus I, and negative 3 minus I. Sorry about that sloppiness. Okay, have a great day.